First presentation will be given by my dear colleague Shravan Chunduri. He's our head of technology based out of India, and Shravan will let us know what he has researched so far on trackers in the market. Shravan, the floor is yours.
Okay, so hello everyone. Today I'm going to present the latest results, what the latest trends we have learned in solar tracker segment. My presentation is essentially a summary of preliminary results of our research for TaiyangNews market survey on solar trackers. Before I go into the main topic of my presentation, I would like to take this opportunity to provide a brief introduction of our company. We are actually two companies and we have two platforms. So TaiyangNews is an open platform. Here we publish reports on advanced PV technologies. We also publish market surveys on various production equipment and process consumables. As you are today attending, TaiyangNews is also our platform for making virtual conferences and technical webinars. So that the key differentiation with TaiyangNews is that it is an open platform. That means all the publications can be accessed for free, but we also have a consulting arm called Mishko, through which we provide services, of course, for a fee. Our services include communication strategy development, technical research, and market intelligence. With consulting services, we go much deeper in specific topics. As I said earlier, this presentation is a summary of our preliminary research we have done for our trackers market survey. We will publish the survey very soon. As to what to expect from the survey when it is published, we will include basics of trackers along with some explanation about the types of the trackers. We will provide an overview on the tracker suppliers. The survey will mainly discuss the latest techno-commercial trends in the tracker segment. And a few of which I will already discuss a little bit, but not so very deep. Then survey will also include a detailed product description and tables listing the important specifications. As I said, we have already started working on our survey. That means we have sent out the questionnaire, something that looks like this. Then, requesting the information to list key specs of the trackers. If you haven't received a questionnaire from us, please get in touch. If you haven't sent it back, please do send it. Well, most of our list, the companies in our list have answered. A few are still missing. And if you want to stand out from your peers, you are welcome to do so by advertising in our survey. For your reference, our last year's survey featured input from 19 companies that have provided the data for 34 products. Here are some basics of the trackers. So the basic function of tracker is to follow the sun. While manual trackers did exist, today's trackers are pretty smart and have become very, very sophisticated. As to the types, there are more or less 3 types of trackers, but one can argue there could be several more, but these are the mainstream. So one is a single axis tracker that have 1 degree of freedom. So it can be, the freedom could be either in horizontal or vertical direction. Then there is a dual axis tracker that have 2 degrees of freedom. However, in today's utility scale PV plants perspective, single axis trackers, especially the horizontal one, are exclusively used. So HSAT, which stands for horizontal single axis trackers, are the are more or less the state of the art in today's tracker segment. These trackers use motors, drivers, sensors, and controllers, that enables them to position the module at optimum position to face the sun in most effective way, so that the absorption is maximum. But if you would like to have more details about the trackers and their designs, their important parts, we have covered all these fundamentals of these trackers in our previous survey, which was done by my ex-colleague Olga. So it gives very nice details about the fundamentals and basics, and you can download the report at our website for free. Here is a just glimpse of the trackers market. As we all know, bifacial is being increasingly preferred module technology of choice in utility scale PV. Since bifacial module perform better when they are combined with trackers, the market share of trackers is growing along side of the bifacial. So actually here what you see is an old estimate of 2020 estimate of ITR PV about the trackers, their share in global PV deployment. The roadmap actually then estimated that the market share of the trackers would increase from 30% in 2020 about to 40% in 2030. But I'm pretty much sure this is really more now already. However, ITR PV has not been covering the trackers since then. At least I have not found any info on trackers in the last editions of the last 2 editions of the roadmap. Today's market really offers a wide variety of trackers. So tracker manufacturers offer different mounting options for the module. So one in portrait, so this is called 1P, or 2P, which is 2 in portrait, or 2 to 4 in landscape. Here you can see these are 3 in landscape. But the majority, at least according to the last year's survey, because we haven't received the data for the current survey completely, the most of the companies are offering 2P trackers. And so there are different driving motor mechanisms, so AC, DC, brushed DC motors and brushless DC motors. However, the high-end tracker solutions are based on brushless DC motors. So all this, whatever I'm discussing on this current slide, it's according to our previous survey. So this is the gist of our previous survey. And as far as the powering source, so taking power from the grid is one way. Making the tracker autonomous using PV and storage is also an interesting option here that is becoming more and more common. And companies from different follow different approaches for control of the tracker, such as closed loop, open loop, and there are different variants of the open loop like AI based. Stow angle is also an important aspect of the tracker. So climate is changing, and not for better, so we have to be very careful towards the extreme weather conditions. So wind-related failures are widespread in trackers. So companies are rather following different strategies for stowing angle. So they are like, few are doing 0 degrees and some are doing 30 to 50 degrees, and some are even using different stow angles for exterior and interior rows based on the wind tunnel testing driven design. And some offer different stow positions for wind, storm, and hailstorm. So really completely different angles. And there are also different trackers installation concepts spread across the industry, something like on-site workshop assembly, pre-assembled parts, and standard tools, or specific tools for faster installations. Or there are several methods. And here I will present a few trends we have learned during the preliminary research. So the top of the list is obviously the bifacial. So bifacial is really becoming the key ingredient of PV technology mix. Not only PERC is bifacial, every advanced technology is bifacial. So costs of bifacial are same or at least much closer to monofacial. So this really depends on the price of the glass, because at cell level, the costs are more or less the same. At the module level, it a little bit depends on the BOM, the bill of material, but again, the prices of these materials have been varying quite differently. So I think as of now, it's very close, the price difference between the monofacial and bifacial. And then, you know, combining the bifacial with trackers gives a synergistic effect. That means 1 + 1 is actually more than 2. So bifacial is top priority for tracker makers. So the main key design aspect here is avoiding the torque tube shading, and several torque tube designs developed to meet this criteria. And 2P configuration, which supports this kind of design very much, is actually gaining more popularity on this account. You know, then there are also some smart tracking methods, such as flat array position favor you know, bifacial by overcast sky conditions. You know, one of the major development in the entire PV segment is larger modules. So the larger modules are having a different impact on different parts of supply and value chain. And in terms of trackers, these larger modules bring higher weight and larger form factor. Excuse me. These are a kind of a challenges for trackers, and leading tracker suppliers have optimized stability to accommodate larger modules. Now, you know, 1 year back or 2 years back, this was a big challenge, but this is not anymore, at least from the leading suppliers. Tracker makers are increasingly focusing on designs that can sustain higher wind loads. I actually don't want to steal the thunder out of the storm from Antai's presentations. They will speak about the wind load and optimized designs. You know, moving into the another interesting approaches of the tracker. So adapting to the terrain is really very interesting function of the tracker. For example, Nextracker is offering such a control software that can control each tracker row independently, so that it can eliminate the row-to-row shading. You know, that may be because of several factors. So something like geographic conditions, terrain, or weather. So the tracker rows can be controlled independently, so there is no shading, and they find the optimal angle at every point of time. And of course, you will also hear more from Nextracker on this subject. Another interesting tracker configuration with respect to terrain is tracker suppliers are coming up with all-terrain tracker, which is nothing but designed for rolling terrains. So that means the tracker simply follow the terrain. So let's say roll with the terrain. And Nextracker again has recently launched a product for this. The benefits actually of this particular design are several. So it does not require land grading or flattening, which not only adds up to the project cost, but also time-consuming process. The technology not only applicable for small variations in terrains, it also enables higher sloppy terrains, which were earlier not feasible for PV plant installations. So it also avoids paying premium for the flatlands wherever it is applicable. So put it simple, the rolling terrain approach improves the utilization of the land, which is, I think, going to be a very important topic in future. So then applying artificial intelligence to solar tracker control is again very interesting approach. Trina Tracker will shed more light on this aspect in today's presentation. With AI, the trackers are able to calculate optimum tilt angle for various weather conditions and terrains. It also helps in increasing the bifacial gain by differentiating between the overcast skies and a few scattered clouds in the sky. Then agrivoltaics is actually gaining a lot of traction in these days, and it is really growing as an important application arm of PV. So it enables farming along with the power generations. Of course, there are some specific dedicated designs and structural configurations that are specifically designed for agri PV, but however, trackers can also make a significant contribution to the agrovoltaics, because basically they can move according to the sun. So that means they can also be configured according to the needs of the agricultural requirements. And a few tracker manufacturers are taking this aspect as serious, and they're providing custom-made solutions designed for agri PV. Another interesting aspect what we also saw is to reduce the logistic costs and meet the delivery times. A few companies establishing local procurement channels. So, for example, Nextracker has opened 3 new production sites in US. And slim design is another aspect. So it is no surprise that tracker makers are trying to save on steel. The price for this metal has increased considerably in the recent time. At Intersolar, Slater has introduced a tracker based on a slim design, meaning the steel consumption has been reduced to 20 to 30%, if I'm not wrong, but at the same time not affecting the reliability. Another important aspect, a lot of tracker companies, especially who are catering to the clients in Europe, are also seriously working on reducing the carbon footprint. And trackers not only improve the yields so far what we have seen, but they can also help in shaving noon peaks, which result in negative tariffs. So the approach is named as anti-tracking by University of Massachusetts. It is nothing but turning the solar panel away from the sun, probably very easy job, by means of a closed loop control manner. The approach smartly avoids the energy dissipation, but restricts the production. So I think it's very self-explanatory how trackers can help in this aspect. And trackers are gaining a lot of traction due to this feature. So now I come to the conclusion of my presentation. Actually, today's solar trackers are really sophisticated and increasingly becoming smart with several functions. While traditionally trackers were mainly considered to be good fit for bifacial based utility projects, agri PV might be another emerging application. Noon peak shaving may turn into another USP for the trackers. There are really a wide variety of products available right now in the market, and there are also several developments in these aspects like mounting options, driving mechanisms, power source, and controls, and so on. I think the most important trends, what I just already discussed, are bifacial, larger modules and wind loads, products adapting to terrains, AI-based controls, less steel, and local supply. Thank you very much for your attention.
Thanks, Shravan, for this nice overview. Very much looking forward to the report.
Sure.
Yeah, I found it really interesting, actually, this aspect of trackers being used as an intelligent tool, actually, to address this topic of solar becoming more and more mainstream, and address also the needs of electricity markets. So I think it's not only about curtailing or avoiding curtailing by stoving them away, but I also heard recently from one developer that in Central Europe, they are thinking about using trackers simply because they believe that when they sell on the wholesale market, that electricity prices will be simply so low that it makes much more sense to generate electricity in the morning and in the evening, like a little bit like with east-west facing systems, to get higher prices. Okay, very cool. Thanks.